In the world of mega infrastructure projects, one of the most important challenges engineers face is the ground beneath the project. In this series, we will explore some of the most important soil improvement techniques used in major engineering projects around the world. We will look at how these techniques work, how they are implemented, and how they help engineers improve weak and problematic soils. And today we begin with preloading and vertical drains. Preloading and vertical drains, also known as PVDs, is a widely used ground improvement technique for soft and highly compressible soils. The basic idea is quite simple. A temporary surcharge load is placed on the ground to simulate or even exceed the future structural load. However, in soft saturated soils, consolidation can take a very long time because the water trapped within the soil cannot escape easily. This is where vertical drains become extremely important. Prefabricated vertical drains provide short drainage paths for the excess pore water pressure to dissipate. As the excess pore water pressure decreases, the soil consolidates, settles, and gradually gains strength. The vertical drains are installed into the soft soil using a specially designed installation rig. A mandrel carries the prefabricated vertical drain to the required depth. After reaching the design depth, the mandrel is withdrawn while the drain remains embedded in the ground. A large number of drains can therefore be installed over the project area in a relatively short period of time. The main objective of this technique is not simply to produce settlement. The goal is to achieve the required settlement before construction of the permanent structures begins. The technique can reduce total post-construction settlement, reduce the time required for consolidation, increase the shear strength of the soil, improve stability during construction, and prepare the ground for future development. So, how does the system work? When the preload is placed on the ground, the additional load initially generates excess pore water pressure. The vertical drains provide drainage paths that are much shorter than the natural drainage path through the soil. Water therefore moves horizontally toward the drains and then upward through them. As the excess pore water pressure dissipates, the effective stress in the soil increases. This leads to consolidation, settlement, and an improvement in the engineering properties of the soil. The system consists of several basic components. First, the site is prepared and the unsuitable topsoil is removed where required. Then, the prefabricated vertical drains are installed using a PVD installation rig. A separation or filter layer may then be placed, depending on the ground conditions and project requirements. After that, the preload or surcharge fill is placed over the treatment area. The ground is then left for a specified waiting period to allow consolidation to take place. During this period, settlement and pore water pressure are monitored to evaluate the progress of consolidation. Finally, when the required degree of consolidation has been achieved, the surcharge can be removed, and construction of the permanent facilities can proceed. One of the major advantages of vertical drains is the significant reduction in consolidation time. Without vertical drains, consolidation of thick soft clay layers may require many years. With a properly designed PVD system and preload, the required degree of consolidation can be achieved much faster. The design must consider several important parameters, including the soil properties, drain spacing, drain depth, surcharge magnitude, required degree of consolidation, and the expected settlement. Field monitoring is also essential to verify that the ground is responding as predicted. Preloading and vertical drains is therefore a powerful technique for accelerating consolidation and improving soft, compressible ground. And this is only the beginning. In the next episodes of our Soil Improvement Techniques series, we will explore more techniques used to prepare the ground for major engineering projects. Stay with us, and let's continue exploring the engineering behind mega projects. At Engineering Treasures Academy, deep foundations are different. Learn, understand, then execute.